Hey guys, Miss O'Donnell here again. I have 5-minute time limits on my videos, so this is part 2 of multiplying polynomials. Our goals are still the same: simplify polynomials using multiplication. So now what we're going to do, we just went over the distributive property and how to use a box model to multiply to distribute. We can do the same thing, except now we're multiplying polynomials. You'll notice here I have two binomials, x plus 1 times x minus 3. They're both being multiplied. So I already have my box set up. I already have both sides of my box filled in with what is being multiplied, what that side represents. And then I can just multiply and write the answers on the inside of the box, right? So x times x is x squared. Negative 3 times x is negative 3x. X times 1 is 1x. And 1 times negative 3 is just negative 3. Now, to get my final answer, I have to go through and actually do the addition and simplification, right? So I have x squared minus 3x plus 1x minus 3. You want to really assume it's all addition between your different inner squares. So technically we could say that's a plus a negative 3 and plus a negative 3. And writing it as addition allows you to use that commutative property of addition, right? To move things around as you need to, right? I see right here, I have two like terms, so I can go ahead and simplify that. X squared plus negative 2x plus negative 3 would be my final answer for writing this polynomial. And it's really nice how it's already written in standard form, so I don't have to do any more rearranging. Now, that being said, I want to take a look at what this x plus 1 times x minus 3 looks like on Desmos. So let's hang on real quick. Let's take a look. Okay, so hopefully you can see my Desmos screen. And you see I've already graphed x plus 1, x minus 3. So there's a couple of key values that you want to pay attention to here, right? Hopefully you notice if we look at our x-intercepts, our first x-intercept is at a negative 1. Notice we have a plus 1 in our equation. Our second x-intercept is at a 3, positive 3. Notice I have a minus 3 in my equation. Okay, so that's something to keep in mind. Another thing that you might notice, remember our final answer when we multiplied was x squared minus 2x minus 3. So if I wanted to check and see, let's see here, let me change the color here. If I wanted to check my work and make sure I really multiplied correctly, I could go ahead and type in both. And as long as I have overlapping graphs, I know that I did in fact come up with an equivalent expression. Something else you might notice on this graph is this y-intercept is at negative 3. And hey, check it out. That last digit being subtracted in our equation is giving us that y-intercept, that minus 3. And there's some reasons for that, and we'll look at that as this unit progresses. Okay, so let's do another example, right? So you can do this distributive property area model for multiplying polynomials, right? So really, the area model is just a nicer way to organize that larger distributive property, where I have my 3x minus 2, my 4x plus 7, right? So I'm doing 3x times 4x to give me 12x squared, negative 2 times 4x to give me negative 8x, 3x times 7 to give me 28x, and negative 2 times 7 to get negative 14. If I check that out on the distributive property side, I'm doing the exact same thing, right? 3x times 4x gives me 12x squared. 3x distributing to that 7, or times 7, gives me 28x. Negative 2x times 4x gives me negative 8x. And negative 2 times 7 gives me negative 14. I got the exact same terms, whether I used my large distributive property or I broke it down using the box model. Okay. Again, you want to make sure you simplify completely. Oops, I forgot a squared. So you should have that 12x squared plus 20x minus 14 as your final answer.